Good morning. I know that. So it looks like we're going to have a pop quiz at the end of the class.
Heck no. You should think that we don't have to do
Oh.
Yes. I didn't realize you showed up for class, you didn't have to do discussion board.
Yes. Ooh, that is a possibility, but we may talk about what's in the discussion board.
Well, we can do that.
All right, so you'll just be ahead of the curve. So, a couple of things we need to do this week. We're working primarily in Python this week. So we need to get a couple of documents. You need to make sure that you do have Python installed, and I think everybody in here does. It's certainly on the computers. There is in course documents a zipped folder that you might find useful. And that zipped folder has the source code for every one of the assignments that's in the book, so that you can see what they actually should be. We're going to actually do a lot of them as we go, and we may modify them, but it is a handy resource for you to look at them. So everything that's in the book, all the programs that are in there are actually listed in that zip file. So you can actually use it to compare. The reality, though, is if you're not doing the material along with the book, you're going to be sadly lost pretty quickly. So you need to be practicing along with the stuff in the book. But this gives you some pieces. One of the things I use it for is there is some text art in there, and we're going to show you what some of that ASCII or text art looks like. And rather than recreate that, because that is a very time-consuming piece, I've actually will use that just to grab it out of it. But if you download this, you need to extract that folder and place it somewhere where you can use it fairly frequently, or wherever you're putting the rest of your Python documents. So I'm going to grab that really quickly, and I'm going to place it in the same place I have my documents here. So downloads. There's this file. It needs to be extracted. So I'm going to do the extract all. Takes a couple of seconds and it'll pop up another folder here. I am going to copy that and place that in the location I'm putting all the files for this class. And so notice it's organized by chapter. So chapter 1 has a program called Game Over. And if I go right click and I go to edit that with idle, that's just demonstrating that we can hold our text open or our program open by this input. The program can't close. It's waiting for us to input something, so we can't close the program at that point. So we look at chapter 2, chapter 3, chapter 4. There's other ones in there that you can then grab and utilize. So in chapter 2, we're going to go through most of these programs. There's a couple of them that have some text art in them, and we might use those as a way to grab those items. The other piece from last week, remember, right spot, documents, is we created our class template. And so we're probably going to add some pieces to that template. So that's just a great way to start out your program. It starts Python in the idle window. If you just right click on it, you can also start Python just by typing IDLE or finding the appropriate icon on the Mac if you're using that. So interactive mode, script mode. I noticed in the assignment that several of you flipped those around. Interactive means it interacts directly. Excuse me. Each time, script mode means we're writing a batch script, if you want to think about it that way. It's some way that we can create a longer program and it works programmatically. All right, so in chapter 2, if you'll flip your book to chapter 2, so chapter 2 starts with the idea of a useless trivia program. All right, who's printing? All right. So if you didn't notice, we do now have a printer in the lab. The costs on it are going to be monitored fairly closely. So please don't come in and print like a 60-page book, but if you need one page or a couple for a class, feel free to use it for that. So introducing the useless trivia program. And so the useless trivia program is the first one of these that has this idea of ASCII art. And so on page 17, it shows us that game over, all done in what's in text strings called ASCII art. And I am not going to make you recreate that because that would be kind of silly, but we can cut and paste pieces of that out. So I'm going to open up that source file, and I'm going to go to chapter 2. And I am going to look at the useless trivia program. I'm going to edit it, open it with idle. And so notice I have a ton of these open. I thought it was the useless one. Hang on a second, let me make sure. Game over, sorry. It's the game over one has the ASCII art in it. Alright. So notice it's got these triple quoted strings. So the triple quotes allow us to maintain this entire piece. Well, that looks really great, and there's an art to writing those kinds of things. So before they had the ability to put graphics and fun things on the screen, this is how we had to do a lot of our artwork on there. I'm not going to force you to recreate that. We're going to look at a lot of the same concepts, and then we'll cut and paste in this particular statement just so we can see what it does. So I'm going to move this off to the side, and I'm going to grab a new program here, new program window. And like all of ours, we always want to end our program with an input statement that's going to lock out this program from closing. And so, because I have it available, I'm just going to copy and paste it in. This is the only class where I'm going to tell you copying and pasting is really a great idea. The other thing I always want to do is make sure that I have something on the top that says what I'm doing. More importantly, when you're turning things in, that it's got your name on it. So this, we're really just exploring the ability to do different print statements and seeing what will happen within some of those print statements. So print is a function. We send it out to a function inside. And so whatever we put inside of those quote marks and those parentheses, it changes how we're going to utilize some of that. So on page 18, it starts looking at using quotes inside a string. So usually what this book will do is it'll show you a section of code, and then it breaks it down into what it's looking at. So if I'm going to do a print statement, and one of the things to be careful of is make sure you always do it lowercase. It's very easy to want to go print, and notice it doesn't change color with that. And when it doesn't change color, that tells me that I've not got the right keyword in there. So print should always change color. And notice when I hit that, it actually says, it gives me a little details. It says I can put away pieces, it can show me what to do. So it gives me some hints on what's going to go in there. So what I would like to do is print program game over. And notice what happens inside of here. So program. So anything I want to put in quotes, it's going to print. It's going to say, oh, that must be a text string. I want to print that. But I'm going to print program game over 2.0 because we've written a second version of it. But I want to put part of this inside of a quote to output that as a quote. And so I can do that by using that single quote mark on the inside of that. And so anytime we do anything, I always hit that F5, and I'm going to save this as documents, my Python, and I'm going to call this trivia. No, this one's game over, sorry. And so it's already going to tell me, hey, you've got an invalid syntax when I do that. And notice I didn't end and put a parenthesis on the end of that. So now I can fix it, run it again, and it actually says game over, and it puts the little quote mark inside of there. So anything inside those double quotes gets printed. So we want to try a couple of things, and one of the things we want to try is we want to see what happens. Can I put a print statement on the same line? So I'm going to do another print. And we do a lot of different print statements. So I'm going to put in a couple of messages. Same. And I'm going to put in message. Now the question is this going to print on one line, or is that going to print on 3 separate lines? What do you think? How many think it's going to go on 3 lines? How many think it's going to go on 1 line with a space between them? How many think it's going to go on 1 line with no spaces between them? So this, how we set up these print statements, and they're just experimenting with them, is the only way we learn and remember how those work. So I'm going to do an F5, save it. And what did I do up there? Trying to talk and type at the same time is always dangerous. I've done something weird. Oh, hang on. It's actually up ahead of that. I put a period instead of a comma. All right. You can. I can actually push the screen out to you if you would like. If that would make more sense.
That won't work for me.
That doesn't work for you? All right. Yep, nope, that's right. Or set it one of the other ones, or yes, either way. Turn off the lights if it would make it easier for you guys to see. So in here, maybe I could even make it look a little bigger. I don't know if I can change the format of that a little bit. So notice it actually does. It puts a space in automatically between each one. So we can list a set of items in here. So if we had another set of names, we could do that really easily. That white space, we've talked about that before. So I'm going to print another statement. And I'm going to put in this statement. And I'm going to put a comma in. And I'm going to go down a line just to see what happens. We'll also now I have this another statement. I actually put them on different lines to make it look a little easier for me to type and create. But when I run this, and again either F5 or the run, notice it does actually put them all on a single line. So it makes it an interesting piece of code here. So as we can put these all on different lines, it puts it back out on one line. So then the question becomes, how do we get to put in a new line? And you've already actually seen how to do that. You just didn't realize what it was yet. So in our input at the bottom, where we hold things open, let's just take that. Notice that it says /n/n. If I come up here and at the beginning of will also, I put that /n/n, and maybe I do that on the print line also. I'm going to save this and reprint, and oh. And notice what it actually did. it put in 2 lines of space. So that new line character is actually that /n. So if I changed it to just 1n, and I run it again, notice now it says it just put a single space, so it returned right after the end of one. So that new line we could put in a couple of times. So if I wanted to put in a whole set of spaces for some reason, notice that it pushed it down that many lines. So that /n, and we're going to see a couple of other ones that does slashes, even though it's inside of the quote marks, it doesn't print, nor, well, it doesn't print, and the program interprets it. So even though it's inside quote marks, and it should be left alone, you think, it actually, the program sees it and says, all right, I see what you want to do there. So we can modify those and change those a little bit. All right, so on page 20, they talk about the triple quoted strings. And that's how we do like that ASCII art like we have over here, this game over. That triple quote allows an entire block. So I've got this entire block of code, and if I just copy and paste that in, because I want to do it the easy way, and I don't want to have to type all that in. Now when I run this, so all my other statements worked, it pushed this down, and whatever we do in those triple quotes stays out here. And so we use those a lot for things like end of games, beginning of games, at your introductions, maybe your information about a particular thing. So it's one way we can do that that makes life really, really a little better. We're not going to get to the part where we're doing fancy graphics in here, so we're stuck with doing this for now until we get a little further along. Move that back out of the way now. So our program got a little bigger. Now it's got several print statements. We've already started looking at how do I get rid of, or how do I use these those end characters for a new line. So there's another one. So if you flip to page 21, they start talking about them, and they call them escape characters. So there's a couple of other ones we can use. I'm going to delete some of this just so it's out of the way here. So the other one we use all the time is a T. And if N stood for new line, T probably stands for, it's a refreshing diet beverage, 3 letters long. We do them all the time. It's above the shift key on the left-hand side of the keyboard, 2 characters up. Tabs. Yeah. So we can also tab in a character. And so we can try to see what happens then if we put in a tab on something. And you can see how it will move those in. And we use tabs a lot because we can format our text a little better. And notice here now we did a tab stop from there. So if we did it at the beginning of this program or this line, now it's going to tab over. So run module. And so notice here it moved it over 1 tab stop. And so you could do some printing, and you could see what will happen. Well, here's the interesting part though. Maybe I want to actually print one of these. So how are we going to do that? So if I want to actually print that /t rather than have it used as an escape character, and I know this won't make a lot of sense in our print statement, but if I just put two of them in, let's see what happens. So remember, it's on our print on a single line. And notice now, if I put two slashes in there, it actually prints the character. It doesn't print both of them, because it still sees that escape character, but it will actually print that item out. So you have to be a little careful when you're using these. If you're trying to put a lot of tabs in, that you don't accidentally hit two of those, because what you'll actually do is print the character instead of getting it used as an escape character. So there's several others, and I don't know if it will work on these computers or not. We'd have to try it. But there actually is a way to sound a single bell. And that, when we first started programming 40, 50 years ago, we didn't have a sound card. We couldn't create voice. We could do a couple of sounds. And so the way we could do that in Python, for example, is we could do it on a print statement. And there is so A will actually do a bell sound. Oh, excuse me, guys. I managed to catch what, as my wife calls, a man cold. So I apologize for that. So /A. Now, one single bell sound, and we'll see if this actually works on this computer. I don't think it will. Yeah, it doesn't actually run anything. But if it were able to sound a bell, it would be one little tiny ding. Well, the way we could modify that is by how many times it rings and the frequency. And so we could actually modify that to create some different sounds. So some computers, depending on the setup, will allow you to ring that bell. Some of them won't. So on the top of page 24, there is a table. And that table has a lot of the backslash commands that are in here. And so we'll use those quite a bit. So there's the tab, there's the new line. The bell is a little less useful, but the quotes are fairly useful when we start trying to create text and we start having text that we want to output. And when we try to format that text, it makes a lot of difference how we do that. So the next one we're going to look at is something a little different, and it's called concatenating. And really all concatenating means is to join together. And so we're going to try to join together strings of text, and we're going to do it really hard. It's really hard to do. We use a plus symbol. So just like you can add decimal values together, we're going to show you how you can add together text strings to make them into a longer single text string. And right now, since we're not putting them into a variable, it doesn't make as much sense, but it's just a way we can show that we can do these kinds of things. So on the top of page 25, we show you what's called the silly string program. The one thing that we really do with this that's interesting is we also show you how you can repeat some text. And so I am going to delete everything except my header and my footer. I'm going to rename this to silly string. So now I have a new program. I'm going to do a file save as. So it's got a new name. And I'm going to call this silly strings. And I'm going to show you how we put several things together. So I'm going to do a print statement. And again, I typed it right, so it turned purplish. And I'm going to put a string together. So you can concatenate so there's a a slight difference here, and I'll show you what that. All right, so I have a line here. Let me make this a little wider. So I say you can concatenate or put together plus strings to create a plus single string. So there is a slight difference when you're trying to output these. And when I run this, you can see that difference. I'm going to run. Yes, I do want to check it. And it says you can concatenate or put together strings. And notice here, is there a space in there? So when I use the comma to output different things, it automatically puts a space in. When I do the concatenation, it actually says, nope, I'm going to put that all together. It really becomes one string. So I'm going to have to put a space in. And notice I did on this second one to show the difference. Now I can run it, and it will put those together, strings to create a single string. So we can concatenate text. Well, that's pretty handy. And in fact, we can do it on multiple lines. And they show you that in the next line. So they're putting a huge amount of text together. And I'm actually not going to duplicate that in class right this second in terms of time. What I want to look like is something that's a little more interesting to me. So some people like coffee. And when I like coffee, do you like just one cup of coffee or do you like many cups of coffee? Any coffee fans in here? Yeah, you don't just drink one cup of coffee. You might drink 4 or 5 or 6 cups of coffee. So I can do something interesting. So I put coffee, and I use the plus operator to concatenate things. What happens if I hit the times operator and I put times 12? And so right in our string, we don't have to run a loop, we don't have to do anything. Look what I just did. Coffee, 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 coffee. Now, if I wanted to then, could I add a new line character to that and put it on a new line on each one? Well, let's try. And that's one of the things we need to do is you need to be able to try these things. Now, in this case, is that right? I know it's hard to see up there. So the has to go inside the quote string. I'm going to run it. And now instead of doing it just in one line, a straight line, it just puts it out in a list. And if you think, well, I'm going to make my computer really mad, I'm going to do 1200. We could run that module. And notice what it did there. It goes, oh, we squeezed all your text. And that is a new feature in idle. Before, it would just string along and show all 1,200 lines and just keep scrolling down. So, kind of a new interesting feature. Most of the time, we wouldn't really want it to do that anyway. But 12 lines, it does that really, really well. We didn't have to create a loop. We didn't have to do anything. So in our text, we can actually do that. We can use the times command, which I think is kind of an interesting one to do that. So we've learned how to concatenate. We've learned how to put things together. We've learned how to repeat strings. So if I want to put something down, and we want to do that multiple times, all I have to do is put that times character. Python is really, really easy. it looks like English. I wanted to make that say coffee 12 times. I just took it times 12. Well, we also know that our program is going to use numbers. And in fact, we know that the code behind everything is always just numbers. So we need to think about a couple of things. And one of those is, can I just print out numbers directly? Do I have to do anything strange? Because right now we haven't yet introduced even variables. We've done it in the pseudocode, but have we used a variable yet in here? No. We haven't declared one, we haven't used one. So we can do something kind of interesting, I think, is we can actually print and manipulate numbers inside of our code. So if I print, and I don't put them in quote marks because, yeah. So I'm just going to put some numbers in here. So if I have 12 times 3, and I run this, let's see what happens. And it actually says, hey, you've got 36 of this. I'm going to change this to a smaller number just so it doesn't take up the entire string. So notice I put 12 times 3, and it actually said, you've got 36. If I put those in quotes, though, so maybe I want to put out a value equals 12 times 3. So now I've made a statement that's going to do a little bit of math and display. So 12 times 3 equals 36. And I did that by saying my text string had 12 times 3, and then I put it in as just 12 times 3. And I can do that with all different kinds of operations and different numbers and values. So on the bottom of page 29 is actually a list of the most common math operators. There are some others, and so we'll look at a couple of them. We have addition, subtraction. Those are pretty common. We've seen those before. So we could add numbers up if we wanted to. So we could do a print statement and say 4 plus 4 equals comma 4 plus 4. And we hope that that's going to generate a value that looks normal to us. 4 plus 4 equals 8. Great. We can divide. So we'll start another one. So print 126 divided by 2. I'm going to put that in quotes so that we remember what values we're going to do. Equals 126 divided by 2. So we've got addition, we've got subtraction. Notice, though, something different. What happened when I divided? What is the difference between these numbers? Is there something that looks a little different? It gave us a 0.0. Interesting. All right, I'm gonna keep going. So I'm gonna try this same problem. I'm gonna copy this line, and I'm going to, instead of a single dividing line, I'm going to put 2 in there. And notice it returned it as a 63 without a decimal. So what it's showing is we have different types of numbers that we can use inside of Python. A number that has no decimal fraction is called an integer. And if we want to work in integers, integers are easy because they don't have that decimal fraction. We can actually use a special math operator. And so that whack whack with 2 of them in there says I want a integer only. And we know that 126 divided by 2 really is 63. Well, what if we put in a number that should give us a decimal fraction? So if I change that to 125, and I'll just do it up here so we have the same scenario with. So now we see one says 62.5, the other one just drops the fraction portion and gives us only the integer return. We can use this to our advantage. So how many of you have made change in your life? Everybody has. And when you hand somebody change, you're trying to give them the biggest change possible, right? So the first thing you do in your head, if I said you need to hand somebody a $1.25, is you're going to say, I want to divide it into the largest coins I can. And you would start with usually a quarter and divide it out. And so we can use that technique to get some information out of it. Now right now we haven't got the variables in there, but we can use that piece. The other one that is probably unique to you is something called the modulus operator. Any math majors in here? I know there's one at least. So have you guys used the modulus or modulum?
Yeah.
So what all that returns is the fraction portion. And so between the two of them I can get the same answer, but in some cases I want only that fraction portion. So we can do the same thing. I'm just going to copy this. And I'm going to run a slightly different operation in there. So, chunk, just so we can see what it looks like. All right, and I'm going to run this. And notice what it returns is a 1, because that's how many times that actually would get divided in there, if that makes any sense. It'll make more sense when we start doing variables, and we start looking at those a lot more. So right now we're just trying to get started on the idea of mathematical operators and what kinds of things we can do. So to really use these and make them powerful, we need to understand variables. And what kind of variables. We've been using them in our pseudocode, so there's nothing new here. So I'm going to change a couple of things in here. And I'm going to go ahead and just delete part of my program here. So we have all our math operators. We're going to come up with, and we're going to declare our first variable in Python. And I'm going to call that name. And I'm going to set that name equal to Mark. So this does a couple of things. It says, all right, I created a variable. I assigned it a value. And I'm also going to create a second variable. I'm going to call that name2, just for giggles. And I'm going to assign that a blank value. Well, now I want to print, and instead of having to put in a name or a quoted object, I'm just going to put in name. And if I run this, my hope is it's going to print out Mark. And it does. Well, now I'm going to put in Mary. And so I want to try a couple of things here. And I want to see if we can get it to print out that second name. So I'm going to have to use my other variable. Now normally we're trying to be very descriptive. In this case we're just using a couple variable names to do some demonstrations with. So I'm going to run it again, and I hope that I can use both variables. So I can have Mark and I can have Mary. So depending on which variable I use. So I can mix those up. I can say, hi, name2, and it should run and print out and say, hi, Mary. So I can get a character variable pretty easily. And one of the things about Python that's really nice is I didn't have to declare up there and say, I'm declaring a variable named name. It is a string character with X number of characters. Python holds my hand. And it holds my hand really nicely and says, oh, yep, you're going to do that. And it's a variable, and we'll take care of the details for you, which is really kind of nice. So, a couple of things on a variable. So, on page 32, they talk about naming a variable. Well, name is very self-descriptive, and there's some general rules we want to use. I want your variable. What we really want is what they call self-documented code. In other words, when I look at that code, those variable names are so clear, and the code is so clear that, yes, hopefully you'll put some comment tags in there, but I'm not having to depend on the comment tags to understand what's going on. And my variable names are very concise and very user-friendly. We don't want to just have, because I could just have X, Y, Z, P, but that's not very user-friendly. So there's a list of these down here that are great things. So, descriptive name. Consistent. So in other words, generally we want to do either one or two methods of naming, and we want to do it consistently. I personally like camel casing. So in other words, this is a variable name. So in other words, I have to put them all together. I can't have spaces. The computer doesn't understand what to do with spaces. So I created a variable name, and I used what's called camel casing. The first letter I did not capitalize, but every word after that I capitalized. And our brain will see that and be able to read it. The other method, and it's more just to do with my typing ability, is to underscore. So again, we can understand it, we can see it, but we want to be consistent. If you go to work at some place, they will generally have these rules laid out for you. But in our case, we can pick one. I want you to be consistent. So in other words, if you're using camel casing in one part of the program, use camel casing everywhere. Otherwise, you'll try to use those two variables, and they're going to go, nope, that's not a variable we've ever seen before. So while we want descriptive names, you can't go too far overboard because you are going to use those names again. So somewhere between usually 8 and 20 characters is usually a pretty good length. Under 15? As long as it's reasonable length. A reasonable length of characters. You can, in fact, go 255 characters long. And it gets ugly because then you have to try to copy those. And we don't copy variables very well when you're typing. So you'll end up making some issues with that. So, other languages have other constraints. So there may be other things we have to deal with if you're in another language. But Python really makes our life pretty easy for us. So, if I try to reference a value, so I've got some variable names here, and I'm going to delete this one out just for now. And I want to see what's in this, so I'm going to go print. And I haven't assigned it a value. I just want to see if there's anything in there. And I'm going to get an error. And it's going to say, whoa, this is a variable name is not defined yet. Now, I don't have to actually define it as a string because once I use it, it self-defines. So in other words, if I would have said, copy it so I don't have to type it, equals blank blank, so even though it doesn't have any value, I have part of the quote mark in there. Hang on. name. There we go. So I'm assigning it a value. And now it printed it, but it printed just a blank line, right? So if I actually put content in here, now it has content. So I do have to declare them. What's interesting is I don't have to declare what kind of variable or any specifications right now. It just says, hey, you've got a variable of some type. You can use it for whatever you'd like to use it for. So that being the case, we can do a couple of really interesting things. We can get an input and put an input from somebody really easily. So we could say, we're going to change it. It was Mark. Now we're going to change that to an input statement. So name equals input. And the input is pretty handy. It actually allows us to put a comment or a text string up first. So we can put in, hi, please enter your name. And then we can actually print that output. So you could say, we can use it in some way, print thank you for playing name. So notice a couple of things we've done here. So I'm going to hit run. And it says, hi, Mary. Now it has content, so we didn't change any of that. Hi, please enter your name. And it says, thank you for playing, Brett. And notice we have changed that variable. It was Mark, and it became Mark, and then it changed to Brad in this input statement. So we can get input out of a user pretty easily. So on page 34, they talk about the input function. So we can get input from a user. We can use that at the beginning of our program. We could use it anywhere in there. And in fact, fairly quickly, you're going to find out we can enter almost any value in here. One limitation of this, and we'll talk about it later on also, but everything we take in as an input is a string. It is a set of characters. If I want a numeric value out of that, I actually have to do a conversion. And so we'll look at that here in a little bit. But Python's got a lot of string manipulation pieces. So on page 36, we're going to create and look at some of those string manipulation pieces. So this one we'll call quotation manipulation. Again, I'm going to put in, just so we get in that habit, because I guarantee I'm going to find code that doesn't have that when I pull it out. And so we need a quote we're going to use in here. And so we're going to use quote as a variable. We're going to set it equal to, and this is actually a really good quote. So it wasn't that long ago, and the chairman of IBM actually said, there is only a world market for 5 computers. So I think there is a market for only 5 computers. And I shortened it down just a little bit there. So I have a quote, so I have a variable. And so I can do a couple of things. I can print, and I'm going to change this just a little bit. I'm going to say original quote. Print quote. And if I hit F5 and I save that as quotation, it says, all right, there's a market for 5 computers. Got it. And I maybe want to change that. And so one of the things that we can easily do is doing things like uppercase and lowercase. And so we're going to do this one in uppercase. So I'm going to do another print statement. And to make sure it moves down a line, I'm going to go ahead and I'm going to put in a couple of new lines so it moves down. Quote in all caps. So again, I'm going to do a print statement, but I'm going to do something slightly different in here. And we touched on this just a little bit about using dotted notation and functions before we got out of our other book. And so I'm going to put quote dot upper. And I'm going to open and close a function, and then I'm going to close it again. So there's actually a function inside of a function. I am using that dotted notation to call the upper function. And so let's see if that actually works. Quote, original quote, quote in all caps. Well, that's pretty cool. I can also do it in lower, and I can do it in other styles. But it's an easy way I can manipulate string text. And on page 38, there is a list of different things we can do. So a couple of those are pretty easy. Upper and lower seems to make sense. Swap case sounds interesting. So I'm going to try this in swap case. So let's do a print statement. Just so I can remember what I'm doing. And I'm going to print quote dot swap case. And because it's a function, we end up with an open and close parenthesis and then an end parenthesis. So we can run that then. And it actually does. It swaps the case for, in this case we only had a single capital letter, but it certainly would be kind of interesting to do that. So we can also do some other things. So we can swap uppercase, lowercase, italics. We can do the title case. We can do all those fun things. But we can actually manipulate the quote. And so there is one called quote replace. So let's try that one. So print, just again so I remember what I'm doing, quote replace. And so this one will take our same type of print statement, and again we're going to put in quote dot replace. In that case now, instead of just being an open and close, so a void function, we're actually going to put some items in there. And so we first have to put the one we're going to replace, so 5. And then we put what we're going to replace it with. In this case, we could say millions of phones. that's a little more complicated. The other piece, though, I want to see at the end of this, does it change this quote? So I'm going to come back up here, and I'm going to print the original quote again. So I'm going to copy this and put it down here. Because I want to see if it actually changed the quote, that variable, or it's only a temporary substitution. So I'm going to do F5. And so notice now it says, I think there is a market for only millions of phone. So, but on the next line says, I think there is a market for 5 computers. So it doesn't actually change this value. We're just manipulating how it outputs for now. We're just manipulating how it outputs. So there's a lot of different things we can do with text. So those are not the only string methods we have, and as we go along, you're going to find we have some other ones. They allow us to manipulate that string so we can throw it out, we can add them together. So we can do some interesting things if you wanted to in here. So we can actually add 2 quotes together. So we could actually say quote equals quote plus quote. So what do you think that's going to do? So notice what it did is it actually added, so the original quote, it doubled it because it actually put them together. Just like we did with when we were just outputting that text. Now we actually changed that original value, that value in there, because we added a piece to it. Maybe I wanted to say, instead of add that, plus space worldwide. So let's see what happens there. Does it actually manipulate that? And notice it actually changes that. We actually used a plus symbol to concatenate or add that in there. So we changed our string. We actually changed it, not just the output of it. So we can actually do that also. So there's a lot of things we can do with our strings in terms of output and inputs. Numbers are where we would like to head. So we can do a lot of string work, and that's kind of fun. The value, I think, in our computer, though, is it does that thing that we don't like to, and that is add, subtract, divide, play with numbers. And so we're going to look at creating some programs that manipulate numbers. And so we have to think about the numbers. So right now we've seen strings, and we've seen integers, and we've seen floating points. So floating points, in other words, it had a decimal fraction on it. And so we want to really quickly create a program that we can do some values with. And so we're going to start. I don't know if we'll get it done here, but we're going to introduce the Trust Fund Buddy program. So I am going to delete everything inside here again, just so I can start with a new blank. And we're going to call this Trust Fund Buddy. And this is a concern for those people who have large trust funds. So I'm going to do a file, save as. I'm going to call it Trust Fund. So in this particular case, we need to look at how do we start manipulating some money, and how do we start dealing with some values. So we're going to recreate this one, and it starts on page 39. So, bless you. I am going to grab a little bit of content out of my file folder here. So, Trust Fund Bud bad, and I'm going to edit it. And so I can grab this text content here really quickly, and I don't have to deal with that. So there's a big print statement that says, it totals your monthly spending and tries to keep you from getting forced to get a real job. All right. Ignore pennies, use only dollar amounts. Because when you have a trust fund, a large one, you don't worry about pennies. So we're going to get some values out of this. And so the first thing we're going to get is we got to get the car expense. So we're going to say car equals input. And the book says Lamborghini, but I'm going to say Mercedes. We're not that over the top, right? Mercedes tune-up. And then we need something maybe for rent. Equals input. Manhattan apartment. And maybe we need one for games. I'm going to shortcut this a little bit for reasons of time. Input computer games so the only part that really matters as you're working through here is really these 3 lines here. But I also want to output a total. And so I'm going to say total is equal to car plus rent plus games. And then I'm going to print total. Your monthly spending equals total. All right. So now we have a program. We take in a couple of inputs, and our book does a few more. I just did 3 just so we can show you what's going to happen. And so now we have a car, rent, games, and we have a total, and we added those 3 together. So I'm going to hit F5 so I can save it, and it will run. And it says my Mercedes tune-up. What is a Mercedes tune-up going to run you? $1,000? Manhattan apartment. Ooh. $10,000 a month maybe? For the cheap one. And what's it going to cost to keep you in computer games for a month? $200? $0. And I add those together. Bam. Whoa. Wait a minute. That doesn't look right, does it? Huh. So wait a minute. Let me run this program again. So I'm going to come back over here and I'm going to run it again. Because I have a sneaky suspicion. What if I say for Mercedes tune-ups, I say bad, Manhattan apartment is expensive, and computer games are worthless? Sorry, Liam. Your monthly spending is bad, expensive, worthless. Oh. Wow. So what is it actually doing? What is the problem, do you think, here? So what we input so the total equals. So remember earlier where we showed that you could add strings together? So all it's really doing is adding those strings together. It's not a numeric input. It's just a set of strings. And it's saying, hey, I really am adding together. I'm doing exactly what you told me to do. So we need to come up with a way to change that just slightly. So there are some additional functions. So one of the functions we can use is we can use a function called integer. And so I just wrapped up that entire input in an integer function. And what it does is convert whatever's inside of there into an integer. So I'm going to do that on all three inputs, and let's see what happens. And notice I have to wrap the whole thing around there. Now, there's other ways we could do it, but I'm just going to see if that will work for me and see what happens. So now I'm going to put in $1,000 for tune-ups. My Manhattan apartment, I got a bargain. Oh. So it actually works. Our program, our logic was sound. We just needed to do a little bit of syntax change to make that work. Now, are there other ways we could have done it? Yeah. So quite frankly, what we could have done, so I'm going to take this back out temporarily. We could have got this input, and then I could have said car equals to integer of car. If that makes more sense. I just combined it into one line. Right on the microphone, that's good. Sorry to everybody online that's watching that. All right, so I could combine those, and I could do it this way, I could do it that way. I could even possibly come down here and just get an integer of just the total. But that's probably going to give me something wrong. And we could try it, but I'm going to tell you it's going to be wrong already, because it's going to combine all three strings and then try to get an integer value. So here's my question. I'm going to leave it this way so you can see that both ways will work. What if I put in Mercedes tune-ups are bad? Oh, it doesn't like that, does it? So there is some value in doing some error checking. And right now we're not quite to that point, but do you think we could design the logic to check if it's an integer or not? And if it's not, come back and loop and say, nope, your answer wasn't correct. Let's output the correct value for me. So it does error out. If we say we want an integer, and it doesn't error out when it takes the input. Where it errored out was when it tried to convert it. Because it tried to convert bad into a number. And it didn't like that at all. So let's say Mercedes tune-ups. Let's see if it does the same thing if I type bad here. And it does. And it's in that conversion from one to the other. So we always want to make sure that we error check. And right now we're not quite to that point, but you and I look at it and go, well, why would you ever put in a non-numeric number? Or why would you put in something that isn't a valid number? And the reality is, people are dumb. They will do things that will astound you. And they don't always follow logic and follow rules. So, please read ahead. On Thursday, we'll finish up the chapter. We're pretty much through a lot of the content. And we're going to start looking at how to convert from different types of values to another. And we're going to start creating a way to start making a useful program. And in fact, your assignment this week is you're going to create a program for a car dealership. And so you can get the appropriate price. And so we're going to go through some of the pieces on how to do that on Thursday. Hopefully it will be a short, simple assignment because I know everybody is not going to want to work on things over the break. So we will pick that back up then when we come back. All right, so on Thursday, make sure you have read the rest of the chapter. And we will, in class, probably have a discussion over the discussion board. You already turned it in, didn't you? You're just ahead. All right, let's get out of here. Enjoy the nice 4-degree weather outside.